Hi everyone, so in this video we're going to continue our lesson on nomenclature, which is naming and writing formulas for ionic compound. Specifically, we're talking about ionic compounds that involves a polyatomic ion. Right? So on your periodic table, your polyatomic ions are given. You don't have to memorize them, but you do have to be able to recognize them. So one of the examples we did in class, or we haven't finished in class, was to name this compound, CuSO4. Okay, so the first thing I do is I separate the metal with the nonmetal and ask myself what type of metal I have and what type of nonmetal I have. Okay, so if you look at copper, and we zoom into the periodic table here, copper does come in two different charges, 1 plus and 2 plus. Right, so I'm going to figure out which one it is. Cu1 plus or Cu2 plus. Okay, so this is a multivalent metal. And if we look at the nonmetal, SO4, we know that it's a polyatomic ion because it consists of two elements. So our regular nonmetal usually only have one element. But if you look at our polyatomic ions, okay, down here, they all have more than one element. So we look for SO4, that's our sulfate ion. Okay, so I'm going to zoom back out. So this is a polyatomic ion called sulfate. So that means that our name is going to be copper, and we have to tell people which one it is. So we're going to need a bracket and then sulfate. So let's figure out which copper we're using. One way to do this is to do trial and error. So if we bring sulfate back, let's do a trial and error. Sulfate is SO4. If you look at the chart again, it's SO4, SO4 2 minus. Okay, so SO4 2 minus. And if we were to do the crisscross, you would get a 2 and a 1, which is invisible. So you would get Cu2, SO4 1. Which, if you look, it's not the question that was given. So this is not right. Okay, so that means that we are using Cu2 plus, but let's just do a double check to see if it's right. Okay, so a sulfate, SO4 2 minus again, and then let's do our crisscross. 2 and then 2, which reduces to 1 and 1, and it's invisible. So if we use copper 2 plus, we'll have Cu1 and then SO4 1, which is what we have. So now we know that we are using copper 2 plus. So in our name, we're going to say copper 2 sulfate. Okay. The next example that we had, which I don't remember exactly, I think was NH4 and then Cl, or NH4b or NH4i, one of them. Okay, so again, I'm going to separate my non-metal, metals, and non-metal. So now you might ask, well, NH4 is not a metal, because if you look at nitrogen, it's on the non-metal side, and hydrogen is definitely not a metal. But what happens is, again, you notice that it's a polyatomic ion. And how I know is that it has more than one element. It has nitrogen and hydrogen. Okay, so if you look at the polyatomic chart, NH4 is right here. It's our ammonium ion. Okay, so we're going to go back here, and we're going to write ammonium. Okay, the reason it's written first in the name is because ammonium has a positive charge. Right, on the table you can see that NH4 has a positive charge. So it does behave like a metal, because all metals have positive charges, and it will be written first. So it's not a metal, but it behaves like a metal because of the positive charge. Okay, and then we look at our chlorine. Well, this is just a regular chlorine nonmetal. So this is just a regular nonmetal. And for any regular nonmetal, it has to end in "ide." Okay, so this compound will be named ammonium chloride. Right? The last example was NH4OH. So people look at this and they get really confused because that's not a metal that they see, and this is not a typical nonmetal they see. So how do you separate this? Well, the more examples you do, the more familiar you will be with the polyatomic ions. So then if you look at this, once you are used to seeing it, you'll see NH4 as a polyatomic ion. Again, from the last example, it behaves like a metal, so it's written first. And then OH is another polyatomic ion. So we have a special case where we have two polyatomic ions bonded together. So the only thing we have to do is to name them, right? So if we look at our chart, NH4 is right here. That's our ammonium. So we can write down ammonium for NH4. And then our OH here, it's our, oh, my chart got cut off, I think. This is our hydroxide. Oh, wait, no, it's here. Okay, so hydroxide. So this compound is just called ammonium hydroxide. Okay. So that's all for naming. There will be one more video to talk about how to write formulas.